Hi, I'm Lee.
Hi, I'm Cameron. We've been working on an IoT solution which provides smart order processing and logistics tracking.
At the heart of the solution is Sage X3 in the AWS cloud. We're going to be getting sensor data from a driver's smartphone and an Internet of Things device. We will then send this data up to the X3 cloud instance at an interval defined by the company or the driver. A customer will be able to query the company's social media account 24/7 without the need for an employee replying. For the company's benefit, there is a responsive web dashboard which allows data from every current and past journey to be shown on an internet device. Warnings and problems from the sensor data will be shown on the dashboard so that the company can react quickly to remedy any issues.
So as the story goes, we are a medium-sized business looking to order products using my business management solution Sage X3. My app of choice is Facebook Messenger, so I log in and start to communicate. We will show you how that works now. We're getting data back from X3. This interacts with Facebook Messenger. This chatbot system named Alex will answer questions from the user. This is a fully cross-platform solution, so as long as you have Facebook Messenger available, Alex will be available as well. I'll now move on to a quick demonstration. This is the bot inside of Facebook Messenger. We wait for a response from the bot, and then we ask our question. Alex will then look inside of X3 and see if there's any stock for that product. It has found 4 Raspberry Pis in stock. It then brings up this window where you can choose where you want to buy the Raspberry Pi from, and then you can use Sage Pay or Bitcoin.
Now, onto the Pi. I've got an instance of the Pi running on screen just so you can see what's happening in the background. This isn't needed in the real world, but it's good to show you what sort of config data is needed to run the device. First bit of data you need is the MAC address of the sensor tag. This is in here so if you ever need to change the sensor tag for whatever reason, it can easily be done without changing the code. The second is the poll timeout. This is the amount of time in milliseconds in which the data is sent up to X3. This can be changed to faster or slower depending on what sort of goods you're carrying. So for example, ice cream, that could be maybe 15 seconds, whereas something less perishable such as fruit can be a minute. The third is an optional, but it's the NFC delimiter. This is the piece of data needed before and after the text on the NFC tag to ensure that it reads correctly. Now, I'm gonna run the device. First of all, you need to turn the sensor tag on by pressing the button on the left hand side. When you press it, a green light should flash to let you know that it's searching for a connection. I'm now going to run it, and as you can see, the config data has been loaded from a file, the NFC port's open, and now I can tag the NFC tag to update the journey ID. As you can see, the journey ID has been updated to signify the specific journey, and temperature data and humidity data is already coming in. As you can see there, we've got a success, which means that it's now published in X3, and this will keep going every 15 seconds. Perfectly fine. You can also update the journey ID mid-drive without having to restart the Pi. So I'm now going to do it with this white tag. As you can see, the journey ID has been updated to 1. It will now publish it with that new journey ID. If the NFC tag's not working, as you can see, there's a one that I haven't put any data on yet. I'll tag it, and it'll show an error. And this means that it'll state the journey ID it currently is, and it'll still work on the old journey ID. This will stop any sort of bad NFC tag from ruining the function of the device. And what I want you to do now is, there should be 2 tags, a red and a green. Give the one which you think this is. This green's cool, so we'll tag it on cool. Or if you think it's uncool, tag it on red, but We know you're going to want to pick Google.
This is the delivery portal that the driver will see. He can then enter his driver ID and his journey ID to start sending data up to X3.
Journey started.
Once the journey started, he'll get audio feedback telling him that the journey has started. That will then send data such as location data and G-force data to X3, ready to be taken in by the control panel. This is a control panel that the delivery company will see. They can enter a journey ID, press enter, and then they'll see the data on a Google map. This is the location data. We can see the advanced location data here, where you'll get the longitude and latitude. You can see the journey start and the latest location. We can then click show location to see the full address for that location. We can click on show issues to see any issues with the driver or the van. That means if the temperature threshold is too high, too low, or if the driver has braked too hard or accelerated too hard. As you can see, no issues were found on this particular journey. We also have temperature data. So this is all of the temperature data that's been recorded for this journey. We can show the highest temperature, the lowest temperature, the highest humidity, or the lowest humidity. We can also show all the data, and that's to provide feedback on the whole journey. That's it for the control panel. Once you place your order, you can then ask the bot where the location of your package is. The bot will then respond with data from X3 and present it on a Google map. If you have any problems with the order and you'd like a call back, you can ask the bot for a call back. The bot will then try and find your number, and if the number is incorrect, you can change it. We will then type in the new telephone number. And as you can see, it responds with, "We'll get in touch as soon as possible."
This solution can be bought for much less than a traditional system. It can be bought for about £50 or less than $70.
That's it from me and Lee. Thank you for watching.